Hello, Python friends. A little bit about me, Jack Diedreich. I've been doing Python for 15 years and other languages for even longer. The purpose of this talk is just some small tips and tricks, how I think about writing a function. Function's a very accessible thing. It's 5, 10, maybe 20 lines of code. If you can write a function, you're a programmer. Congratulations. So in a small body, you should be able to figure out what's going on pretty easily. Most of your things that you post in CRs, code reviews will be a small basket of functions. You should be able to just look at them, not have to explain them to the reviewer. So this is how I think about functions and some tips and tricks. So we're going to cover thinking about function structure, how to help the reader, which at first is you, because you read it once when you write it, you read it again before you post it for review, and then you have a little back and forth with the reviewer, and it might be you many, many times in the future as well. So helping the reader get context is important. And then at the end, I'm going to have some things that you can kind of ignore if people give you feedback in code reviews, because they're not strictly helpful. All right, think about function structure. Once again, we're talking about functions. We're talking about something that probably fits on a page. So it might seem weird to think about it as having phases. And these are pretty broad phases: input, transform, and output. So the input might be the 2 lines at the top, the transform might be the 2 lines in the middle, the output might be the 2 lines at the end. But when you're helping someone read through a function, which is what you should be doing when you're writing, kind of breaking it up into these smaller sections is a good way to think about it. Input. Input is whatever you do at the top. This is where you're going out and gathering information. You might be making a database call. You might just be using the function parameters as they were passed in. But this is kind of the foundation of your function. You're setting up the reader for this is the set of stuff that you're going to have to deal with for the next 10 lines. And you want to be pretty ruthless in your input phase by throwing out everything you don't want. Because anything in the arguments that you can quickly pop off and ignore lets the reader know that this is not going to be important 10 lines later. They don't have to wonder if there's going to be an if-else that will change depending on the inputs. So if you winnow down your inputs just to what you're actually going to use, you're helping everybody. And this is also where you're going to throw most of your errors. So right at the top, at the start, you're looking at your inputs, throwing out what you don't need, and validating that what you have is exactly what you need to continue. And these early errors are good errors because they tell the reader something about what's not going to happen later. Transform is just where you do the actual work. Say you have a list of people and a list of addresses, and you want to collate the two so addresses get people. At this point, you've already done the validation. So exceptions should be more exceptional. If something goes wrong, something's less likely to go wrong, and you should be very loud about it when it does. And at this point, the reader should be almost bored. Nothing should be surprising at this point. It's a function. So the name of the function is the thing you're trying to get at. Collate people and addresses. All right. So right now in the middle, when you're doing the transform where you collate people and addresses, no one should be surprised. Output, always think pretty printing for output. You're not literally writing a pretty printer that does indentation and other things. But the pretty print here just means you are giving the caller the format of the data that they want. So it may be that the exact same thing you did in the transform step is the data structure that they want, but maybe there's an extra step. Maybe you're posting the file somewhere and then sending them a URL. Maybe you actually are physically printing it to standard out. But the output phase is just you giving the caller the format that they want. Exceptions here should be like super really surprising, because it means something didn't happen in input validation or something failed during the transform that didn't actually raise an error. So it should be like super surprising if you have something fail in output. And the input, transform, output, you shouldn't try to break these down into really strict categories. You shouldn't watch this talk and then go to a code review and say, hey, this is output. Clearly, you should move it 1 line up. It's more of a gradual thing in a function. And once again, we're talking about 10 lines. So some of them might be a mix. But when you're looking at a function, if you see something that's clearly output as the first thing, just be like, hey, maybe this should go at the end. So I said inputs are the most important thing. If you get these right, everything else just kind of flows. So when thinking about inputs, you're thinking about what you have, what you need. So it might be that what you have is an account ID, and what you need is an account object that has all the other associated information for the account. It might be that you actually only want the email address for that account, but you start with the account ID. So you're coming up with a short list of the information you have and the information that you're going to need in order to do the bulk of the work in the middle, and throw out the rest. So if you have information that you don't need, just throw it out. Thinking about this in terms of information is kind of a practice. Anytime you look at a problem, this is a little glider in Conway's Game of Life, you can play spot the information. So there's not a lot of information here. It's just a list of which cells are on. So you look at this and say, hey, this is just a list of cells. Same thing, you look at a chessboard and say, okay, this is a list of pieces by position. There aren't a lot of real life scenarios like this. Even if you do like the Project Euler problems, those are great for practicing lots of different kinds of problems, but not for looking at inputs, because it's a small problem, well-defined, and they give you exactly the thing you need. So they don't give you two pieces of information, one of which you should ignore. They give you exactly the amount of information you need. So those aren't great for practicing this particular thing. But in real life, you're dealing with, say, a Django ORM. And the quickest way to get a list of all the users, we want to see how many names we have that are palindromes, that are the same front to back. So the first thing you do is you want a list of names. Maybe you're given the users, so you can't do a better SQL query here. But anyway, you end up with a list of user objects. So in your input right at the top, you want to tell the reader that literally the only thing from this list you're going to use is the names. And the best way to do that is to immediately just make a list of names. I don't advocate doing something like del users so that it's out of scope and like super duper tells the reader that you're never going to use the users again. It's okay if it's a short function. They can scan down and see that you don't use it again. Just make sure you don't use it again. Because then your users might be different than your list of names, and it'll be very confusing. But anyway, we get the users, we get the names. All we want is the names. So then we have our transform and output. The output is just one line. It's the last line. Okay, that sounds pretty good. And we go through the list of names, determine if it's a palindrome, and print it if it is. Great. Some other small things you can do to help the reader is return early. I personally don't think this is very opinionated to say. Here's an example of why. So we have a function called delete all users that takes a dry run flag. Dry run means don't actually delete all the users. Great. So we get a list of users, and then if dry run is true, we say, okay, here's what I'm not doing. I'm not deleting this many users. All right, this is pretty readable. If you don't return early, you often see code that looks like this. So this is a negative for the reader. You just caused work for the reviewer, because the first thing they have to do is go from the immediate top of the function and scan the whole thing. Because this is a loaded gun. You've promised that you're not going to delete the users, but the reviewer's job is not to trust you and go down and make sure that you don't actually go and delete all the users. So do the easy thing. Return early. The reader has extra information now. Not only are you not returning the users, the dry run flag is not going to come up again. If the dry run flag happens later down in the function, then that's an error because you can't get there. The gun on the mantle. So in the theater, the saying is if there's a gun on the mantle in Act 1, it should go off in Act 3. And the reason is you have the whole play to build up suspense about what's going to happen with the gun. And the people in the audience get enjoyment out of wondering, is this going to happen? Is that going to happen? This is absolutely not the thing you want when you're writing code. So if If there's a gun on the mantle, it goes bang. So define things next to where they're used. This is the easiest way to make sure that things are actually used. It makes it much easier for readers because when there's a value at the top of the page that says max retries equals 3, when someone is reading way down in the function call level and it says something equals max retries, great, now they have to go look it up or just trust you that it's something sane. It's not really helping anyone. So when you can, put those constants right next to where they're used, and especially where you can, just put them in the function default signature. So the whole thing of putting constants at the top of a page or in another module called constants is kind of inherited from C. So how do you specify a function default in C? You can't. So what do? You put it in the include file. And how do you tweak parameters in C? Well, you put them in the include file. We don't have those restrictions in Python. You can really just put it in line where it's going to be used. You'll often see a file that has like 3 of these functions that all call different APIs, and they each use max retries, which is a thing at the top of the module. They don't actually have much in common other than the number 3. So they don't actually mean max retries for everybody. It means max retries for this API, max retries for that API. And what happens is later, one of the APIs fails a lot, so someone changes it to max retries AWS equals 5. And now there's 2 constants at the top of the page. One of them just says max retries, and the other one says AWS retries, which is confusing. So you change one to max retries global. And at the end, there's 3 constants at the top of the page, each of which is used in one place down the road. So just, until you have to combine all these things and put them up top, you can just put the number 3 places. It's great. Exceptions. People very frequently define exceptions that are used once and not even always caught. So it's pretty common to see an exception at the top of a module, which again is far away from where it's going to be used. And then it gets raised in one place, and frequently it's either caught in 1 or 0 places. This particular error isn't a great exception name. It says it was raised from this module, which you can tell by looking at the traceback later. And the actual information in the exception is in the message. So couldn't talk to host. Great, that is actually very useful. So if that's all the exception is really adding, you can just use a Python built-in exception. So the amount of material you want to convey, information you want to convey, which is, hey, a traceback happened here. Great, everybody sees that because it's in the traceback message. And the message itself tells them something, which is that they couldn't talk to the host. Names have meaning. In a function, it's pretty easy to grok because you only have 10 lines or so. So there aren't going to be a large number of variables. In a large software system, you might have 4 or 5 things with the name account or user each. You have one for your upstream caller, one for this library, one for that framework. But in your function, you're probably only going to be dealing with one of those kinds of users. So you don't have to say Redis user. You can just say user. Some names you can use to tell the user that they shouldn't care about the contents. Things like raw, data, blob. It's just telling the user, here's a thing that has some unknown format that I am going to use very soon, but don't think about it too much. And hey, sorry, I just got a Wi-Fi. I have a Wi-Fi pop-up. Right. So you can use these kinds of names to give the user a hint that this isn't a thing they should particularly care about, but you're going to be using it soon. Response is a nice generic name. It means I got this response, but you're not responsible for knowing what is actually formatted as. And then the next thing you do is you immediately consume the response and maybe give it a more concrete name. User ob, this is some kind of a Python class. User d, this is probably a dictionary. Or user raw, I'm just getting the raw data, and you still shouldn't care about what it is other than the fact that it's about to become a user. Great. If the reader really shouldn't care about what the contents of something are, we have good idioms for this. The single underscore says this is a temporary variable. The word dummy means I needed a placeholder, and this is the placeholder. If someone names a variable ignored and then uses it later, that's good feedback in their CR. You shouldn't have done that. That's surprising. But ignored is a perfectly good name for an argument that you're going to ignore. There's ways to convey some information about structure just through the names. If you have a list of items, assigning them to the word pair is pretty good. That tells the reader that you think it's a pair. Some better ways is to actually assign it to 2 items. If you don't care, if it's an unstructured pair of items, then left and right are pretty good. It conveys no information about their relationship because there isn't none other than they're 2 of the same thing. If there actually is some structure, then old and new, great names for things, when one's old and one's new. Same thing, primary, secondary, if you're dealing with a pair. Those are great names for things. Who, what, when, where, why. I gave a whole talk about this called Name Things Once. When you're writing an article, you're supposed to say who, what, when, where, and why. When you're naming things in code, it's always what. What is the thing doing? What does it represent? You don't want extra meta. So the rest of who, what, when, where, why is frequently metadata that people tack onto names. It's where I got it from, what I intend to use it for. And in a function, you don't need to know those things. This is just a short contained body. The gun on the mantle goes off, so you don't need to add that extra information. Just what is how you name things. Return consistently. So Python has a few different ways to return none, or a few different ways to return from a function. All 3 of these happen to return none. The first one does so silently. The second one does it implicitly, and the third one does it explicitly. These are all valid ways to get out of a function. But you want to do it consistently. So if you return from a function, if you return something from a function, you should return something from a function always. And you should try to be consistent about what kind of thing you should return. So this particular function returns true and then implicitly returns none. Implicitly returning none, okay, that's kind of falsy. So that will probably work even if you meant to return false. But the reader is going to look at this code and not know if you actually deliberately did this or not. Did you miss a case? We see that obviously you knew when you wanted to return true. How about everything else? You don't know. So let them know that you thought about it. If you wanted to return false, return false. Always return the same types when possible. The same thing as did you really mean to return none? If you are going to return a list, sometimes return a list always. Even if it's an empty list, the consumer doesn't have to do an if none check. It probably isn't what you want anyway, and this will help you do good interfaces. Sometimes you do want to return none instead of an object. This is up to a convention inside your organization, whether you should return a full-fledged object or none. There's an entire field of study about nullable types. So your code base will usually do one of these 2 things. So your code should follow the same pattern. You'll either be able to get the thing you want and return it, and then if you can't, either return none or raise an exception. Just do what everyone else in the code base does. Know that for the libraries you use and the third-party services you call, they might be doing one of those other things. You might end up writing light wrappers around their API just to make it conform with your expectations. This one's from a recent code review I did. Keep it together. So this is actually like really good code. It reads pretty nicely. I can tell exactly what it does. It has consistent return types. So this was pretty easy to give a ship it to. But the thing that gnawed at me a little bit was there was a couple, the functions that it was calling were pretty trivial. This is how much would fit on a slide. There was actually 3 or 4 of these. And again, the functions are pretty easy to review. They're pretty clear about what they do. They're named decently. But the reason you should keep these together, there will never ever be a config in the actual project that hasn't passed validate. So the fact that you have 3 functions here implies that those 3 functions might get called like at any time. They don't. Those first 2 functions only get called during validate. So they're taking up a little space in the module, a little headspace in the reader's mind. And it's not emphasizing enough the fact that they always get called like this. So that second function doesn't have to have extensive tests because it will only ever get called if there's at least some minimum level of structure to the thing. And like I said, there's actually like 4 checks in a row. So the reader can look at it and say, okay, we always go through these 4 steps. And it's a similar thing that there's a create function that mirrors this validate function, and it always does the same thing to create this thing and the same 4 steps. So that's okay. You can just have that in one function. You don't have to make things super small. Linters as attractive nuisance. I currently work on a small team, and we have a linter, and we all agree about how it should be used. That is a lovely thing, and it doesn't happen all that much. There are large companies where everyone uses the same linting rules, and they get applied to every single CR. This is a nightmare. So the people who end up in control of the linter aren't the people who you want in control of the linter. This goes well beyond spaces versus tabs. If you can make a rule that 5,000 other people have to obey, someone really wants to do that. So personal preferences start creeping into the linter. And as far as code reviews go, it's not helpful. So you post a code review, and then it automatically gets marked up with some stuff, and you can push a button that says, please ignore the linter. But the first person who gets on the code review is going to look at it and see a couple yellow warning signs and immediately say, just make the linter happy. And there's one of 2 responses to this. You can get angry at the linter and curse it every time. I had a Twitter account that did that for a while. Or you can kind of embrace the linter. And making the linter happy makes people happy, not for good reasons. So all effort feels like useful effort. That's just a human trait. So making the linter happy feels like, it is effort. It's actual effort. But it's frequently not useful effort. And this pops up again and again. People will give you long lists of rules about things you should do. No function should ever be over 3 lines in length. All right, that's a very easy rule to obey. Well, it's not an easy rule to obey. It requires some effort to obey that rule, but you have a stopping point. And at the end of your refactor, now your functions are more than 3 lines long. Hey, I did a thing, but it's not actually useful effort. Language features. This comes up with language features a bunch. So language features are an attractive nuisance, especially for new coders, because you just saw a talk or you just read a page, and the first thing you want to do is use that feature. Like you start to see the chance to use it everywhere, even in places you shouldn't be using it. You absolutely should learn about all the language features. Dave Beasley does great talks where he takes a feature and just tortures it to death. But you shouldn't actually take a feature and torture it to death in your day-to-day job. You should take a feature and say, hey, there's probably one place where this would be really handy to use, and I'm only going to use it in that one place. But that's a hard thing to learn. So I did these slides the other way around. This is the code that we came up with after a refactoring. So this code should be super easy to read. We have a list of state, zip code, and population. And we want to roll up, it had duplicate rows for state and zip, and we wanted to combine those 2 rows into 1 row just by adding up the head count in each. Great. Hopefully this is like super readable. It took us about an hour to get from the original code to this code. This is literally the entire output of the thing. Again, you'll see that it basically has 3 phases. Each one's pretty short because this is a function. But it has an input where it gets the reads from the CSV file, and the input and the transform are a little bit smushed together here, because again, it's 5 or 6 lines. And then the output is a simple print. All right, so this was at the top of the CR when I first saw it. And there was, so we required 2 shipits before you can push code to Git. And it already had 1 shipit. And I saw this, and I immediately posted the thing, we need to talk. And because like nothing about this class is illegitimate. But the fact that it was the first thing there, and it was de novo, and we'd never needed it before, was kind of a, hey, I'm not sure what's going on. And then the second thing on the next page was this, which uses a group by and a reduce and some lambdas. And I said, okay, let's book a conference room later today for an hour. So you can see, like, this is perfectly valid code. It's actually pretty readable. It's a readable use of the group by function, which is exceedingly rare. It's one of the worst interfaces in the standard library. It uses reduce correctly, and it does exactly the thing it meant to do, which is to take a list of state and zips with head count and roll them up and print out a new list. But that's a lot for a reader to look at, and it only gets used once, and that's a bunch for a reader to look at. It has a bunch of interfaces that most people don't see every day, and that is just, there's nothing exciting about it. This is great. We looked at some other possible refactorings. There's a counter class in collections, and it made that simpler thing even simpler. We didn't use this refactoring because not a lot of people know what the counter interface is, and the collections counter interface is a little bit non-intuitive. It's not always transitive. A plus A equals B, but A minus A is null. Like, it does, it was meant for some use case that I don't have. Speaking of use cases that I don't have, so language features are an attractive nuisance. Python annotations are great at what Python annotations are great at, which is not any problem that I have or have ever had. So for me, they're a misfeature. I just don't use them. They're not solving any problem I have. I have friends who think differently. I have friends who are on the PEP. Great, good for them. Go off and use it in whatever context you're in. Just don't make me care about it. So finally, some other things from code reviews. Back to all effort feels like useful effort. The person who is reviewing your code doesn't want to just give it a blind ship it. They want to say something useful, make the code a little bit better. They're going to have to deal with it later. And some people, like in the case of the linting, just reflexively say something like all functions must be 3 lines or less. And once again, this is not actually useful feedback. It feels like useful feedback because you're doing some interactive things with the other person, the code changes, and then it gets a ship it, but it's not actually useful work. So in addition to short functions, there's some other inspired craziness on the internet. Return once was actually a thing 25 years ago in C. You were helping the compiler. Compilers are better than that now. You can return early. The compiler can figure it all out. You're okay. A new one is no if statements. And this has come up in multiple language communities, and I really, really don't understand it. It literally means don't use an if-else. And that's all it means. So if you can restructure something so that you're getting the same thing by overloading method signatures, then do it that way. It's okay if you actually have a function named if this then that takes 3 arguments, a Boolean, and 2 different values to return. Like none of this is eliminating branching, because somewhere fundamentally your program still has to branch if you want it to do this thing or that thing. It's literally just rewriting code to not have if statements in it. You can search for it. There's plenty of blogs about it. All right, and I'm out of time. So in summary, think about your functions. Functions is happening in 3 phases: input, transform, output. Use sensible names and avoid unnecessary work. Thank you.